Hey students, this is actually lesson 611, real numbers and the number line. It's a little bit of a review, but we're going to talk about the difference mainly between irrational and rational numbers, how to estimate them, how to tell if a number is irrational. So just do this quick review and you can check back for your answers. See what you know about square roots, what you remember. All right, simplifying square root expressions. Again, this is a review. Sometimes the numbers turn out to be whole numbers like this. The square root of 25 is 5 because 5 times 5 equals 25. Now, when that happens, that's a rational number. We'll talk a little bit more about what a rational number is, but basically it is either a whole number or a decimal number or a fraction, then that either repeats or ends, then it's a rational number. And this number also, we could do the square root of 4 over the square root of 81, which is 2/9, and 2/9 is also a rational number. Any number that you can write as the ratio of two integers like this, like a fraction, is a rational number. And since the last number we had 5, can be written as 5 over 1. That's the ratio of two integers, so that's a rational number also. So go ahead and, well, here, circle the equation that uses the positive square root. Pause if you want to do it first, and then wait for your answer. All right, estimate a square root. We can use what we know about square roots to help us estimate. We don't even need a calculator to figure this out. If the area is 220, so area means for a rectangle, length times width, but for a square, it's just the side squared has to equal 220. And what we can do is just think about, well, some number multiplied by itself equals 220, and you could go through some numbers like 13 squared is 169, so it's a little bit higher than that. 14 squared is 196, a little higher than that. 15 squared is 225. So we can say that, if we don't need to be too accurate here, we can just say that S is about, and this means about approximately 15, because 15 times 15 is 225, which is just a little bit more than 220. So we can use a number line to help us estimate square roots. Right halfway between 20 and 30 is 25, which is, and then if we split this up, we have 34 and 36. And then we can also think of square roots in the same way. We know that the square root of 20 would be smaller than the square root of 25, and we know the square root of 25 is 5. The square root of 35 is less than the square root of 36, which is 6. So if we were going to estimate the square root of 34 to the nearest integer, since 34 is closer to 36 than it is to 25, we're going to say that the square root of 35 is closer to 6 than it is to 5. So to the nearest integer, the square root of 34 is 6. All right, you can classify numbers using sets. A set is a well-defined collection of objects. And we have some different sets that we call numbers. Natural numbers are counting numbers, 1, 2, 3, and so on. Whole numbers are positive numbers that aren't decimal and also including 0. So they start at 0 and go up by 1. Pretty much the same as naturals, they just include 0. Integers are positive and negative whole numbers. So this set includes some negative numbers. And here's our definition for a rational number. A rational number is any number that you can write in the form a over b, where a and b are integers, and b is not equal to 0. A rational number in decimal form is either a terminating decimal, such as 5.45, or a repeating decimal, such as 0.333, which you can write as 0.3 repeating. So to be a rational number, we have to be able to write it as the ratio of two integers. Pi, since it doesn't repeat and it doesn't end, is not a rational number. -7/4, that's -7 divided by 4. That's two integers divided, so that is a rational number, so we don't want to cross that one. The square root of 5 equals 2.23, and that keeps going on, never repeating, so that is not a rational number. 0.99999, that is a rational number because it repeats. And 7.35, since it terminates, it ends, that is also a rational number. And an irrational number is any number that cannot be represented as a quotient of two integers. So if it has a decimal, it does not terminate or repeat, then it's irrational, like pi. Pi is equal to 3.141592653, and there's really no pattern. That goes on forever and ever, and that's why it's irrational. Okay, so classifying real numbers. To which subsets of the real numbers does each number belong? Well, we're just talking about the ones we have up there. Natural is one of the ones we can classify 12 as. Whole, it's an integer because that's a positive or a negative whole number. And it's a rational number because it can be written as 12 over 1. Okay? This number ends. It has a decimal on it, though, so we know it's not. We know that it's not a whole number or a natural number or integer because of the decimal, but it terminates, so that means it is a rational number. And the square root of 21, that is a number like 4 point something 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 that just keeps going on forever and ever with without repeating or terminating. So that's an irrational number. All right, I'll let you try and classify some. Go ahead and fill in this box. I'll pause. You can check back with your answer. All right, how'd you do? Square root of 12 is irrational because I hope you tried that on your calculator to check that out. And other than that, the other ones are all, if they're not irrational, then they're rational. If they're not rational, then they're irrational. All right, so just a quick concept summary here. The smallest set of numbers that we've talked about is natural numbers. And the whole numbers include all natural numbers, but 0 is outside of that. So notice that I put that outside of this box. And then an example of numbers that are integers that aren't whole numbers. Remember, integers are positive and negative whole numbers, so I could put like a number -3 there. Rationals include like decimal numbers and fractions that aren't integers, and irrational numbers are outside. That's why there's this line dividing here. That's like a square root of 2 and pi. All right, so what is an inequality that compares the numbers square root of 34 and 5.45? Well, if we turn 5 4/5 into a decimal, we get 5.8. And if we take the square root of 34 and change that to a decimal, we get 5.83095, and that keeps going on forever and ever. That's an irrational number. But we can see that if we compare, this terminates at 8, and this has numbers beyond that. So that means that the square root of 34 is a little bit bigger, so we're going to say the square root of 34 is greater than 5 4/5. So we use decimals to help us compare. All right, go ahead and try this. Check back for your answer. All right, how'd you do? All right, so we're going to use a number line to help us order these from least to greatest. So we're going to try and kind of place these numbers on the number line, and that should help us know where they are. Now the square root of 9 is actually the whole number 3. So we're going to put a dot right there where 3 is, put the square root of 9 there. All right, 0.3 is halfway between 0 and 1 is a half, so 0.3 is a little bit before that. Negative 1/4, if I split the distance from 0 to negative 1 into 4 parts, then I can find negative 1/4 right there. And the square root of 3 using a calculator equals 1.732. So here's 1.5. So about maybe there, 1.732. There's the square root of 3. And negative 4.25, that's a little bit past negative 4, quarter of the way. So if we order these from least to greatest, we're going to start with negative 4.25, then negative 1/4, then 0.3, then the square root of 3, and then the square root of 9. All right, go ahead, you try that. Use a number line to help you. Fill in the blanks, and you can check back with your answer. All right, how'd you do? There's your answers. Okay, just one last thing, lesson check. Go ahead and read this and see if you can get the right answer. You can check back for your answer. All right, that's the lesson. I'll see you tomorrow.